holy smokes, the thing is turned into stone. I understand this, and I will tell you why this is, and we're going to go through how molecules form, and this is going to be a shocker. I can tell you that right now. Okay, my friends, I am going to explain to you, and it is a very simple process. That tank was buried up to the turret. It's just mud you can see everywhere. Wet condition, and it corroded. It is changing it, literally, molecularly adhering to the molecules that were originally the tank and changing them, and it's called nucleophilic substitution. We're going to get down to where we get into the metals, because the metals are what is in your blood. Your blood literally, and I am not kidding you, literally continuously passing back and forth molecules. That's called transitioning. Give me a couple of electrons, take a couple of electrons, back and forth, back and forth. I give you my carbon dioxide, you give me some oxygen, I give you vitamins, you give me some this, you give me, I'll take some of the toxins, I'll bring it down to the liver. This is what blood does. Well, what is in the blood is exactly this. This is the primary mover of your body, is transition metals. What does transition metal mean? Transition means it changes. It changes from one thing to the next. Well, when you have these different metals in your body, they don't just exist a chunk of iron floating around in there. No. That iron is attached to oxygen atom that makes it semi-stable. And as it flows through the body, some other particle in there, a zinc or something, may say, hey, you know, I could really use some of that oxygen. Can you pass it over to me and I'll give you whatever I have? And they do. They flip-flop. They transition back and forth. And then it gets cleaned out and your liver goes through your heart and your lungs. We're going to get deep into this, but the process is, it's called nucleophilic invasion, which substitutes a different molecule for something that was over here. So you originally, well, we're going to get so deep into it. I don't want to take little bits and pieces. It'll just confuse you and you'll get upset. But trust me, are always continuously moving, taken and given. That's why in an aqueous solution, and depending upon if it's got salts or acids in it, it's going to just, all kinds of things are going to change in here. And that is what exactly happened here. And now we're going to get into nucleophilic substitution. Because that's how this foot, which is a no-toe, which is a new speed, complete, and had its full complement of electrons. And then it says, okay, I have been substituted. I no longer have to move through the body and give and take. I am now stable. So here, a stable human lung, DNA certified. I took the DNA out of a hole I drilled in here into where the red blood is. And I sent it off, 100% human DNA. That is from the Great Flood. You see that flat piece there? It died like that. And the reason it disassociated from all of the rest of the body was it was in the salty waters of the Great Flood, and the salt preserved it, and the fascia pleura coating here, which is a rubbery separation layer, membrane layer, that keeps everything in your body separated from everything else. Find out what nucleophilic substitution is all about. Okay, so we've talked about nucleophilic invasion. It's exactly what happened to Jim Burchell and Arlie Caudle's human head. And you can see, it even shows the cartilage and the nose splayed apart, and that's flesh. This is what they would call feldspar. Well, feldspar is nothing more than collagens and keratins and fabric of life that has been invaded by minerals, and exactly what Jim Burchell told Scott Walter. We all know the black and the red blood, and you know, the cracks in the head, and it's about nucleophilic substitution, and that's what happens with flesh, and it just happens. Now, this is, you know, you got to have a little chemistry, but this makes it very simple. All it's telling you is nucleophilic substitution is a reaction, or a class of reactions, a whole broad range of them, where an electron-rich nucleophile, electron in here, they have a lot of extra electrons, attacks a positively charged electrophile to replace a leaving group. So one of these ones that has a lot of electrons forces itself in to stabilize something that normally would be given and taken in your transition metals and your, the life processes, and then it stabilizes it. All right, this really gets kind of complicated, but nucleophilic substitution simply means that your process of your life moving back and forth through giving and taking of molecules in your blood 24 hours a day stops when you die, and then it has to become stable. And it does it by some molecule that has a lot of extra electrons moves in and substitutes itself for the things that would be coming and going, and then it becomes, which is called a leaving group, and then it becomes stable. And I'm going to show you in a heart, which is made from opal. Make it very simple. All right, once again, little chemistry, but not much. Transition metal ion colors. Ions mean they're not neutral. They have a charge. Now, see this transition metals? These blue ones right in this section right here. These are the transition metals. See, transition metals? And what do? They're in your blood. And as they move through your blood, these extra electrons, they need to give and take electrons to go. You need to give and take molecules. And that's what these things do. When you die, they have to stabilize. When they stabilize, a heart takes on, if it can, in a certain condition where opals are formed, the heart will literally become these colors because it stabilizes by attaching to these particular metals, which are here: vanadium, chromium, iron, the whole nickel, cobalt, all these iron. These are your transition metals. It's a little pincher that they have on them. There is what's called a ligand. And that pinches another molecule and drops it off where you need some oxygen or you need some glucose or you need whatever it is. And then something needs to be given up, it gives it up. When it drops it off, it has to take something with it. That's the way it works. Give and take, transition. Now, let's see what happens to a heart when it dies if it has these chemistry available to it and can bond and form its most stable configuration. Watch this. With almost only the transition metals passing through here, so that eventually they will find a transition metal that makes them stable. And here's what it looks like when it becomes stable. All right? Just like I told you, every one of these different fabrics and these different tissues have different jobs, which means they have different chemistry, which means that when they become stable, they want to find a transition metal to invade them, which is called, remember, nucleophilic invasion. Means one molecule wants to find another one, and it has like 6 extra electrons. It looks for something there has 2 electrons, and that makes it 8. You're good to go. There's a lot to think about, but I can tell you one thing for sure. This thing died laying this way, and that is where the heavy metals, and metals are heavier than the plasma blood, which